Present here. This is Vidya welcoming you all to the second day of this one-week online short-term training program on research methodology. Today we have with us two eminent personalities. One is our speaker for the first session, Dr. A.G. Srinivasan, Professor and Additional Dean Research of Dr. MGR Educational and Research Institute, and Dr. S. Manivanan, Dean and Convener of this program. We also have with us Mr. Ganesh Babu, System Administrator of Computer Science Department and Technical in charge on this program. So may I now call upon our Dean, Dr. S. Manivanan, to welcome the gathering, please.
Thank you, Mrs. Vidya. Good morning, everyone. And I'm wholeheartedly welcoming you all for the second day of our short-term training program on research methodology, session 3, handled by Dr. A.G. Srinivasan, Additional Dean Research, Humanities and Sciences of our Dr. MGR Educational Research Institute. He is such a dedicated professor who used to handle a lot of mathematical papers for the PG departments. PG departments of engineering will be handled only by the persons who has got more experience, more knowledge. Like that, in our university, we have earmarked Dr. A.G. Srinivasan sir, who is such a eminent person in the field of statistics, who are, of course, in higher mathematics. Really, I am proud to have such a eminent person for this excellent research. 1,000 plus researchers have enrolled themselves in participating our short-term training program on research methodology. Dr. Srinivasan is such a brilliant scholar, graduated from Loyola College, a prestigious institute, Loyola College, Chennai. Of course, he has done his PhD from College of Engineering, Dindi, which is one of the very oldest institute in the India. And of course, he has a dual degree in statistics also, and that makes a unique characteristic of Dr. A.G. Srinivasan. He is very active in doing a lot of activities in ORSI, also Operation Research Society of India. That's a big aspect that we have to tell in particular. And of course, he is a able administrator. He used to do a lot of work for our MGR University in terms of examination related, examination reformation. If we think automatically, we will remember Dr. A.G. Srinivasan, such a eminent person today we have. Apart from that, he is such a helping person. Whoever approaches him, PhD scholar or PG student of engineering or MPhil students of mathematics, he helps me a lot. Of course, I have sent personally few of my PhD students to take help from Dr. A.G. Srinivasan. He is such a helping tendency in nature. Really, I'm proud to have him for a session. I wholeheartedly welcome Dr. A.G. Srinivasan and my dear beloved participants. Without your support, this event would have not seen the light of the day. And of course, I wholeheartedly welcome you all for this better learning on the day 2, session 3. Of course, I welcome our beloved organizing secretary and moderator of this program, Mrs. Vidya, and system in charge, Mr. Ganesh Babu, who is taking care of the entire technical aspect of this STTP. After my welcome address, just I wanted to share a few general instructions also. Please do not worry about either feedback form or attendance sheet. WebEx records our presence, attendance, everything automatically it records. Since no feedback, no attendance form is separately circulated. Please keep in mind, no attendance sheet, no feedback. It detects everything. It detects whether you logged in using your mobile phone or whether you are using headphone, which is your email ID, which is your mobile number. Everything is being recorded by WebEx. Only thing, my humble request is, do not share this WebEx code, whatever we have posted in our WhatsApp group, to any of your friends. If we find something, if you are sharing with others, surely we will remove the person who has shared from our group also. Please, that is my humble request. And at this moment, I wanted to proudly tell there will be 2 best participant session contests will be held during this STTP. One will be held on the Thursday till what we learn from Monday to Wednesday. Those questions will be appearing as a set of questions on the Thursday, whether it will be posted on either on Wednesday evening or Thursday morning we will post. For that contest, we will select one best participant award. And another one will be posted on Saturday from the syllabus of Thursday, Friday, Saturday. We will be having another contest. So I request all the young and dynamic participants, not only young, all the participants are eligible to attend this to get the best participant award. Beyond your normal e-certificate, these awards also will be given only for the few participants, I feel, based on your score obtained on either Thursday test or Saturday test will be given. Don't worry about any assignment, any attendance sheet, anything like that. You feel free. You just attend the program. You learn from the eminent persons like Dr. A.G.Srinivasan. That will be our main objective. We would be much happy if you could learn from the great eminent persons like him. Based on the score, yes, your merit certificate will be given. And my last humble request is kindly hold your questions of day's session till 10:55 of today. Before you could post those questions, it may not reach the attention of the either panelist or the speaker. Kindly hold the questions. After we inform, kindly post it. Later, we will request the speaker to answer. Today, I am really sure that we will add up to the timing and, of course, happy learning. Enjoy your session. Thank you, Vidya. You can come.
Thank you, sir. Now it's time to introduce our speaker of the day. You see my screen, sir?
Yes, ma'am.
Thank you. So it really gives me a pleasure in introducing our speaker of the first session, Dr. A.G.Srinivasan, Professor, Department of Mathematics and Additional Dean of Research, Humanities and Science, Dr. M.G.R. Educational Research Institute, Chennai. Dr. Srinivasan completed his BSc Mathematics in Loyola College in 1990, completed his MSc Mathematics from Loyola College in 93, MPhil Mathematics in 95, his doctorate from Anna University, Chennai in 2006, his BSc in Statistics from Annamalai University in 2009, and he has additional qualification of postgraduate diploma in Materials Management, Applied Operations Research, and Certified in Library Science. His professional experience, he has over 24 years of teaching and research experience to date. He started as a lecturer in Dr. M.G.R. Educational and Research Institute in the year 96. He worked there till 2001. He was promoted as an assistant professor 2001 to 2004. From 2004 to 2008, he was an associate professor. From 2008 to 2009, head of Department of Mathematics. 2009 to 2018, professor in mathematics. Currently, he is a professor in mathematics and additional dean research in Dr. M.G.R. Educational and Research Institute. His guideship details. He's currently guiding one research scholar. He's guided 5 MSc projects, 2 MPhil projects, 3 BTech projects, and 2 MTech projects. Some of his technical skill sets: Mathematica, MATLAB, MathCAD, SPSS, WX Maxima, GeoGebra, LaTeX, GPSS, and SimScript. Dr. Srinivasan has attended over 15 conferences and he has been invited as a lecturer for over 30 conferences. His publications and projects: he's published over 7 research papers in journals. He has authoring 2 books and 10 project associates. His areas of interest and specialization: mathematical and statistical modeling, optimization techniques, topology, and numerical analysis. Membership in technical societies: Indian Society for Technical Education, Operations Society of India, Tamil Nadu Astronomical Association, and the Association of Mathematics Teachers of India. His other experiences: consultant to Covances, visiting faculty to Anna University, consultant to a private CA firm. So on behalf of Dr. M.G.R. Educational and Research Institute, we really thank him for gracing us with his presence and wish him good luck for his future endeavors. May I now call upon Dr. A.G. Srinivasan to handle the session, please. Over to you, sir.
Can you hear my voice? Yes, sir.
Yes, sir, we can.
At the outset, I would like to thank the organizers, in particular Dr. Manivandan sir, who has given me an opportunity to share my working experience on this particular topic.
Sir, little bit louder, sir.
Yeah, okay. Now is it audible?
Yes, sir.
Yes, sir.
So we start slowly and then slowly I'll write my voice. Okay, so without wasting too much of time, because time is a very important factor, we'll go for the presentation mode. Yeah, is it visible?
Yes, sir. Okay, sir.
One second. Yeah, so this is the program we are all talking about today. This has got yeah, so this is about the sessions, and today this session is 10 to 11:10. I'll be taking the topic on data collection processing hypothesis. Okay, the topics to be covered is as follows: classification of data, methods of data collection, sample size, sampling procedure and methods, data processing, graphical representation of data, hypothesis, types of hypothesis, experimental, non-experimental, hypothesis testing, types of errors and their controls. However, I've been not able to cover every topic because of it's only 1 hour program, 1 hour talk. So I'm going to give you emphasis on certain topics as below. Classification of data, I'll be concentrating. Sample size, I'll be concentrating because for some reason, I'll tell you what it is over the discussions. Data processing and hypothesis. So these are the 4 topics I'll be emphasizing in this 1 hour talk. This excludes the introduction about data. What is data as such means? I'm going to introduce few slides. Okay, so first point is data is everywhere. We all know that wherever whoever speaks, they talk about data. Is it research or projects or organizations? Everywhere data is there. No, so data is now taking the whole world. We all know that the data was not as it is today, because that time data quantum was very little. Now data quantum is heavy. So everywhere data, we can talk about that. And data is not only there everywhere, it is also ever growing. You cannot stop growing the data size. No, it's growing forever. And not only it grows forever, it also spreads in uncontrollable speed. Okay, so I don't want to explain too much about these details, but data must be handled differently than what it was. And then new data comes in to us every millisecond. Every second, plenty of data is plunging to us. New data, new types of data is coming to us. So handling data is not going to be an easy task. So what is data, by the way? It's an introduction. I'm just giving you 1 or 2 slides. Because the definition of data, I'm not going to give you definitions or from the books or the internet, all that. The discussions is going to be an eye-opener for how to do the data processing, data collections, all that. So it's an eye-opener, not chosen from books and giving us a presentation. So this is something out of experience we collected, we have discussed. So first of all, 90% of data we use today or generated the last few years, maybe due to internet evolution, and it's also growing. So there are lots of studies there, how data is now coming to this world, acting, etc. And we talked about Bronze Age, Iron Age, Stone Age. I think now we should say data age. Because everywhere data, as I already mentioned at the beginning of the presentation, everywhere data. So I think we have to call this, maybe this century or some more centuries, as a data age. So I think I have to coin this word, soft word for the discussion. So why data? That's the first question. Now data doesn't just see how much you have, but what you do with it. So you've got plenty of data. The data size, the quantum is huge, but still we should manipulate or we should work out the data as per the standards to get some reliable output. So you should have data, not only the quantum, but also the methodology of handling it. You can take data from any source if it is legal. It can be primary, secondary collection of data. and try to find the answers for the following questions. Like you have to reduce the cost of the problem. Suppose you're reducing a problem, and for the problem you collected data. You must see that the data gives a methodology which is a cost. No, money matters a lot. Everywhere, funding, money means a lot. So data will give us some models, methodologies to reduce the cost and so on. Time reduction, of course, second important parameter. And then you can produce new product, new observations can be made out of the data. And you can take decision making, smart decision making of the data. And of course, pattern on the data. Some of them, of course, I referred some literature. Whatever I referred as the literature, I'm showing the last slide as the references I've referred it. So you can also explore it furthermore from that also. So this is about why data. Okay. The new terminologies in the present scenario of data are data scientist, data analyst, data analytics, data processing manager, data repository analyst, system admin. Of course, system admin some years back is only computers. Now it is only data. So all are data centric. So these are nomenclatures we use in data field. So surprise that data analyst or data scientist is the highest paid job in the global market. Even India is highest paid job. If somebody claims that they have done they have good background of statistics and good background of data analysis, I think they are the highest paid job as one could. You can refer it yourself in the search engines of Google, all that, and find out what is the salary package or how much income per month, per day, per year you are paid if you equip yourself with data analysis. So these are new nomenclatures we use in data science. Okay? Of course, pattern recognition of data, all that. Now let's come to the topic. The topic of the day is collection, data collection, data processing, and analysis. That's what we try to explain what is the topic of the day. Now, before we go for data collection and data processing, I thought I can give you the classification of data first. Because once you've collected data, you must be in a position to classify the data. It's not that we collect the data and study the classification. So classification of data must be known even before collecting the data, so that you collect the data based on the classification you are planning to do. Let me explain what is the classification, all that in the next few slides. So why data classification? So any data intended for investigation. When I say a data, I mean you have a problem, you're going to investigate that problem. So you collected data, some method you collected it, and you're going to now classify the data. I have not spoke about how to collect data now, because I told you already that unless you are equipped yourself with data classification, it is difficult to understand the data collection also. So I just alter a little bit topic, data classification first and then data collection a little later. So you have a data, assume that you have got a data for the given problem, you have to classify. What would happen if you don't classify? I'll give a simple example. This is a sugar. Now, sugar has got several properties. It consists of glucose, sucrose, it is sweet in nature. Now, so many chemical, physical, biological properties sugar possesses. So this is one set of data you have about sugar. On the other hand, this is salt. So salt is another component. It's also white in color, crystal nature. It is salty in nature. So it has got its own properties. So each data, sugar has got different properties. Salt has got a different property. When you mix these two, you get another product, which is going to be again different. It is neither salty or sugar sweet in nature. It's a mixed bag of these two. So when you handle data, unless you classify it, the interpretation about the data is going to be different unless you properly classify it. This is a simple example, a layman's example I'm giving you why you have to classify data. Now, suppose you got a data set. I plot the graph. I got a real-time data set I've collected, and I've just plot the graph of the data set without classifying it. See how the graph look like. Now, there are some good pattern like seismograph or ECG like pattern, but the data is not understandable or analyzable because it's lots of fluctuations. If you are in a position to understand the graph, you see the graph has got plenty of fluctuations. This is because one reason I'm not classifying the data. I just took the data and plot the graph. On the other hand, when I classify by some methods, I'll tell you what the methods are, classification. Once you classify it, see how data behaves. The same data set after classification, see how it grows. You can see the data is increasing. Now, once classification I've done it, and you can see now the same data set, maybe I use laser point. The same data set, here it is very uncontrollable, very chaotic in nature. Whereas after classification, the data becomes very smooth to handle it. It's not smooth enough, but still we can handle it compared to these sort of data sets. So this is one example why classification is very important. Okay, now what would happen if you don't classify, or why you should classify? So let us discuss now why you should classify data. It offers efficient data management. So these words are very technical and anybody can understand from the basic English words. So the data is classified to get the efficient data management. It improves data authenticity. Let me explain an example with this data authenticity. Suppose you are collecting all data related to bank. For example, you would like to know how many customers or enter the bank and get their services. That is one set of data you collected. Another set of data in the bank you are given is the passwords of the bank customers. Both are data. You have to segregate it. You have to classify it. You cannot handle the passwords of the customers of the bank as same as the number of customers arriving in the bank. They are two different data. So you must authenticate to handle passwords by separate group. You can authenticate anybody public to authenticate the number of movement in the bank and so on. So classification also gives us data authenticity. It gives you critical data, which are critical data you must differentiate. It will give you the minimization of errors. We'll explain an example within a few minutes from now. How the errors can be minimized by classifying the data. We'll see that within a few minutes from now. And then you can update the data. Suppose you find in particular group, the data are not sufficient. You can make new data collected on that group. You can do only if you classify it. If you don't classify it, you may have a quantum of data, huge data, and you will be satisfied with that. But when you classify it, you find a particular group has got very little data, so you try to explore. You can get it more and more data. You can update it, upgrade it. You can do sensitivity analysis on the data sets and so on. And of course, you should also have a workflow, a flow chart of what first, next. No, there's a flow chart you can create on making data. So lots of advantages of classification data. I'm not giving lots of examples on classification of data because I would like to spend some key points of the data collection analysis part in the later part of this presentation, which is not followed by the researchers in the beginning stage, and so on. So I'm not going to talk more about that. So how do you classify the data? There are many methods of classifying the data. You can classify based on the data type. I'll give a very simple example. We all know we use social media, like for example, WhatsApp. In WhatsApp, we have got different types of messages, text messages, video messages, audio messages, image messages. So you try to classify data based on that. So that if suppose there is a message in an image type data type, and if the message already has come, if there is an algorithm to identify this message is already there in the data, you can very well remove that message with the image because you already have in your data type. So you can classify based on data type. You can classify the data based on the objectives of the problem. See, you are studying a problem. For that, you are collecting data. And every problem you are investigating, you are studying needs some objectives. So based on objectives, data can be classified very well. So based on data type, based on the objectives of the problem. And of course, based on the volume. Because when the data is too small in size, we can't handle it. If it is too big in size, again, we can't handle it. For example, if somebody asks you, what is the average of, let's say, 1,000 crore data sets? You cannot find the average of 1,000 crore data sets because you don't have a computer to even input the data set. So you must classify it and then make smaller volumes and then investigate to find the average, all the stuff. So you can classify the data based on the volume. You can also classify the data based on the comparison, like gender based, you can classify, You can, based on other reasons, you can classify your data. Based on the characteristics the data possesses. So some negative data can be collected together, some positive data can be collected together, data which are live with 0 can be collected together. I'm talking about numerical data, of course, but each data has got its own characteristics. You can classify data based on the characteristics as well. And of course, based on errors, we call noise in the data. So those data sets which has got, lots of noise, lots of errors can be removed or make us one cluster of data set which has got maximum errors. You can use it for your, checking the data set for new data set in that errors and so on. So you can also classify based on the errors. And then there are other classification. I'm not going to explain too much details on classification itself. So you can classify based on qualitative methods, quantitative methods, and so on. So you can explore it. I given some references how you can classify your data, but without classifying data, the data should not be handled. That's what we try to explain. Okay, now I'm going to give you some simple methods of data collection. These are again, this method of data collection I'm not discussing because basically data collection usually is outsourced in these days because of the quantum of data and because of the varietiness in the data. So therefore, as a researcher, we may not interested in doing the data collection methods. There are professionals, there are professional bodies who does this work. So you can also explore from textbooks and internet how to collect data based on your problem. So this presentation, I'm not going to talk about the methods of data collection. But what is important is, I just give you a few important methods, major methods where you can use data collection. Then you classify the data. I told you why you have to classify, how you have to classify the previous slides. So you can say, for example, questionnaires and surveys, observations, documents and records from the previous, history, focus groups. I think you can understand each and every word from the internet or from the books. All this, I'm not going to explain methods of data collection because it's well-known methods available in the literature. I'm not explaining it. Experiment. You do experiments in the laboratories or in sites and collect data. So these are the methods, well-known methods of data collection. But having collected data, you should do how to do the classification of data, then start investigating the data. Okay. Fine. Now, my presentation is concentrated 30 to 40% on data processing. The reason for taking this data processing into my consideration is that usually researchers, by and large researchers, they collect data, either they outsource this or they collect themselves. Even some of them classify the data and then try to segregate the data and make it. But most of the researchers, from the experience I've seen in the past years, is that they are not doing data processing. When they don't do data processing and still investigate the data, there is every possibility the data becomes a wrong inference of the output. So what I try to say is that data processing step is not done by the researchers usually because they take it granted the data collected is perfect. Please remember, no data in this globe is perfect. Every data has got its own problems. So I'm going to spend little more time of 5 to 10 minutes. What is data processing and how it really works? Now let's start with data processing as such. So this data processing, lots of data, and it is you. Okay, you observe lots of data in front of you. Unless you process the data, it becomes very clumsy, very chaotic, and you see lots of data spreads here and there. So you can't handle it. Even if you classify, even each classification of data may have a huge number of data, so you have to process it. So after classification, classification is not processed by us. Classification is also one of the processes, but it's not the only process. We must do the processing of data before start investigating the data. Let's concentrate on that, how to do data processing. So data processing involves various processes, including classification. We already discussed about the classification. Classification is one category of data processing, but I already mentioned in the presentation that classification is always a mandate for any data you collect. You cannot handle the data just like that. First classify it based on objectives, based on your problem, based on the types. Then your data processing really starts. But usually data processing involves classification also if it is not done before. Then you must also do validation. The validation must be done. That is also called data processing. When you collected data, some of the data required validation. We use in engineering terms calibration, the calibrating of instruments, all that. So data processing also involves validation. So it is not, I'm giving an exhaustive list of data processing. I'm giving which are very important, at least for a researcher to do it. So classification must be done, validation must be done. Only after doing all these steps, one has to handle the data for analysis and inference. Sorting. Sorting means, arranging in some sequence, not necessarily ascending, descending order, but in some sequence so that you really know how the data behaves in that cluster. So again, it is not classification, it is sorting is different. You will see maybe some examples which I've given you in the end of the slide for references. You should know how to sort the data based on the problem. So summarization of data is also comes in data processing. Aggregation is also comes under data processing. So aggregation is combining multiple pieces of data. Okay? And then analysis. Analysis is also comes in data processing. The collection, the organization, the analysis, real analysis, interpretation, and even presentation of data comes in data processing. This is a very important step. Now, people are doing, of course, some steps of data processing, but it is expected to do every step in data processing. We will see in subsequent slides what are the real steps one has to do in the data processing step. And I'm going to concentrate in data processing steps, 2 or 3 very important steps, which is not practiced in the research world. Okay, people take granted and they do it. The data processing, they are doing, of course, analysis. They do, interpretation. They do graphs. But some of the steps which are mandate, they are not doing. As a result, their inference happen to be something, reflecting, from the actual happen. Okay, and the reporting also comes under data processing. I will summarize in a layman's word so that these very hard words, technical words on data processing. I will summarize the data processing, all these in some simple words as follows. It's the most important step, as I already mentioned. It involves categorizing, we call classifying already. The second step is a very important step, the cleanliness of the data set. We'll talk about, this cleanliness in 1 or 2 slides. Now, when I present it, this is bigger than this. So I'm going to concentrate cleanliness and completeness of data set, how to do it, why to do it, what if you don't do it. I'm going to explain that in a big slides. But categorizing, I've done classification already, so I'm not discussing that. Calibrating, validating. So I'm just giving in simple words what is data processing has. Methodologies, I'm going to give you 4 methods. I may not explain these 4 methods today. I will link a presentation which I gave a week ago in our Facebook. You can also check that later. What are the methodologies one has to follow in data processing? But I'll just slide it once and then I will skip that. And then testing, inferring, updating. So I'll be concentrating on the cleanliness. I'll be concentrating on the cleanliness. I'll be just like this. I will concentrate on the cleanliness. I'll be concentrating on this. I'll be giving 1 slide and a link what I gave a presentation last week for your reference. And I'll be talking on the testing also. So these 3 parts I'll be covering. And next few, of course, inference, updating, I'm not going to cover. Okay. Now, let's talk about a cleanliness or called completeness. Let's talk about what is the data of cleanliness, which is usually not done in the research level. There are several reasons why it is not done. Number 1, it's ignorance, that they think, the researchers think the data they've collected is perfect. The data they collect is up to the date, up to mark, and they can process it. But remember, no data will be 100% perfect. We have to do some cleanliness process. I'll demonstrate some simple examples within 1 minute of how the cleanliness really behaves in the data set. So why cleaning? The first part. It improves the efficiency of data set. You have to remove those data which is not relevant to the data set. You have to clean the data so that the data you now have after cleaning is for your problem. Minimize the error, increase the data quality. The quality of data is increased. So before cleaning and after cleaning, if you compare, the data quality is increased. I'll demonstrate a small graphing of how this is shown. Maintain accuracy of the data is very important, because accuracy of data is very, very important for further investigation. Consistency of data is also very, very important, because if data is not consistent, if the data is very erratic, it's very difficult to handle it in the real projects and research. Structure of the data can be maintained, you do the cleanliness, and so on. The durability of data, when you clean the data can be used for other similar purposes also. If you don't clean it, if you take another similar problem or another problem of same data set, you get different outcomes because the data is not cleaned. Let us show a small demo. A quick demo is shown how one can really show the difference in the cleanliness of the data. So I'm going to show a small demo. Now, this demo is shown here. So this is the data set I've collected. I simply plot the graph. You observe it's a nice graph with little ups and downs. I think 6 ups and remainings are all on the surfaces approximately. But what I do is I'm going to run this program. I'm going to run a program behind the screen with lots of new data set added to it without cleaning. I'm not cleaning it. So this is data set without cleanliness. I got completeness. Completeness is a technical word. Cleanness is the English word. So I use the word completeness. Let's I'm going to run the program here in the background. You see the data is running and changing. And you can see the 6 peaks, 1, 2, 3, 4, 5, and 6. The 6 peaks, it's still retained in the data set because it's a wrong, irrelevant data, but it is not going to come continuously. It jumps. Can you see that? You see that here? You see how it jumps? So you cannot predict. See how it jumps. I keep running it for some more time, for a few seconds. You see, now it looked like, it looked like if you take this graph, for example, it looked like there is no error at all because they're all in the same line, but it is not so. These 6 are really errors. I ensure I made my data set which has got errors. Let me run some more time quickly in the background. So you see that I go very fast running. You see now it's almost, of same size, but these are errors. You have to remove this. Okay. Now the same data set I've taken, I removed this, I made the cleanliness process, I did it, and then I draw the graph and see how the graph look like. This is my graph. So this graph is not looking fine compared to this graph certainly, but this graph is certainly better to handle than this graph because this graph has got dirts, it has got errors, it has got noise. You can't handle this data. You should not handle this data. Whereas this data, though it is very clumsy, but it is perfect data in the sense it is for the problem. I'll run this again with some data set. I'll run this program and see how it is all increasing or all decreasing. You can see the beautiful run. I'll just run it faster. You will see how nice. It is done for new updation and validation. Data has no errors. To explain much better, I will take both the data together. Left-hand side, same data set without cleanliness. Right-hand side data set with cleanliness. You will now see how this is working. You can see both are same data set. That's very important. And see the errors are still errors on left-hand side, whereas here there are no literally errors. There are no literally errors on the data set. That's the beauty of this particular problem. I'll come back. So I've just showed you why cleanliness is important. Okay, let's talk about how to clean the data. Cleaning the data is a very important task because I already mentioned if you don't clean the data, there is every possibility that the project will give a wrong interpretation. So you can remove, these are very well-known cleaning procedures. I don't explain how to clean it. Again, you can search internet. What I found is that the researchers are not cleaning the data. So I've taken some slide to explain the cleanliness of the data. But how to clean it, once you decide to clean the data, you can use, literature reviews, textbooks, previous research papers, projects, and check up how to clean the data. I'll just give you a few important methods of cleaning the data: remove duplicates, identify the errors, handle missing data. If the data is missing, you can identify missing data in it, identify irrelevant data, you can identify that also. Verifying randomness in the data, you can use some tests, like for example, Kolmogorov-Smirnov test, focus test, runs test. These are scientific tests to verify to do the cleanliness of the data. Suppose you are given a set of data and you want to check whether the data is clean, whether the data is really fit to the purpose, you can check these tests, Kolmogorov-Smirnov test, runs test, etc. Which of course I'm not going to explain too much about it, because my intention is not to explain the test, but explain to tell you all that you must do the cleanliness of the data. You must do the cleaning of the data before even start analyzing the data. That's the objective of this presentation to start with. Okay, now let's go to the data processing again. So we just see 4 important steps. July 11th, last Saturday, I think, July 11th, in our Facebook live presentation, I gave a 40-minute talk about data processing 4 methodologies, 4 important methodologies. I will not take much about it because you can also see that Facebook topic, same presentation on what are the 4 methods one has to follow. But I will take hardly 1 minute to explain the 4 important methods in data processing: graphical representation, mathematical model, statistical model, simulation model. Let me take 2 minutes to explain how this 4 methods is going to be hierarchy-based methods you can follow in data processing. So when you collected data, first step is you classify the data. Once you classify the data, you go for a cleanliness of the data. You have done the cleanliness very well. Now you are ready with the data set. What you should do is you must draw a graph. You must draw graphs for the data. Now, without graphing the data, kindly don't investigate the data. That's a very, very important step. Now, graphing can be 2-dimensional, or even 1-dimensional, 2-dimensional, or 3-dimensional. But we cannot go for more than 3-dimensional. There are methods where you can reduce the dimension. I already said in the previous topic, in the previous Facebook Live presentation, different methods of using graphical methods. So first thing you should do is, in the data processing step, after classification and cleanliness, go for graphical representation. Without graphs, don't investigate the data. The graph will have lots of advantages before we investigate the data. Okay, once you have done the graphical representation, then you go for the mathematical models. Now, it is not because I'm a mathematician. It is for any branch of research. If you do a mathematical model for your data set, you are most wanted. Don't do statistical model or any other model just like that. Ensure there is no mathematical model, or mathematical model fails. For the data set you have collected, the mathematical model doesn't work for you. Then you go for other models. But if you can get the mathematical model, then you go for that first. Because mathematical model is a universal model, because mathematics is a universal language. So most of the researchers, whether it's from biotechnology or from medicine or from dental or from engineering, even from other disciplines, they don't do mathematical model because it is easy to handle statistical model. But please attempt with mathematical model first, because it will give you an insight how the problem really behaves. In the previous speech on July 11th, I spent some 10 minutes of presentations, why mathematical model, how to do mathematical model, etc. You can go through it again and come back here. I don't spend my time here to do that again. Then if the first and 2 doesn't work for you, then go for statistical model. And in today's presentation, I'm going to concentrate on statistical model, because this is for research methodology where statistics is taken into consideration. So I'm going to talk about the statistical model in this discussion. And finally, I'm going to talk about simulation modeling. I explained 5 minutes on simulation modeling in the previous video. I will just link it here. You can go through it and you can understand, you can explore it yourself, which I'm not going to discuss here. So my emphasis will be on little more on statistical model. We will see what we mean by that after a few more slides on that. There are totally about 52 slides. I mean 25 slides. 15 minutes more. I will skip through next 15 minutes. These next 25 slides. Okay, so these are the graphical representation of data sets, which I don't teach because it's all well known. Anybody can Google it. You can say big search engine, Google search engine, or anything you can try. You can learn different types of graphs, when to use which graph, or you can use that very well, and you can learn. It's not important for us. And then you can go for pie charts, column charts. These things are not that important because I'm not going to spend my time on the graphical version of data because it's user friendly. Even an ordinary researcher can do it yourself using spreadsheets, Excel spreadsheets, LibreOffice, all that. You got lots of softwares, GeoGebras, and other graphs and softwares you can plot. So I'm not going to discuss about that. So I give a screenshot of MX Excel, how many charts, column charts, how many column charts, how many line charts, pie charts, all that. I'm not going to explain about the charts here, but graphic is very important. Graphical method is very, very important for any research problem. Okay. Now we go to constant sampling procedures and methods. So what we have done so far is that we have taken, basically we have taken what is data, and we said data is everywhere, data is ever growing, data is always coming, or new data are always emerging, data is enormous in size, handling data requires lots of training, etc. Then we talked about the classification of data. Then we went on with collection of data, how to collect data. Of course, I was not giving much importance for that collection part because it depends on the problem, you have to do the collection part. Then we discussed about the major steps involving in data processing. Especially I talked about the cleanliness of data. My humble request to all researchers is that any data you collected, first kindly clean it. You have to do the completion of data before investigating it. Most of the researchers, in my experience, I've seen they are not doing it. They are giving data what they have collected and say this is correct, they can execute it. But you can't execute it unless it's cleanliness. And I told you how to do cleanliness. Some methods are given and some links are also given to you. Internet, you can search about the cleanliness processes. Some testing also is given. Then we talked about 4 important methods of cleaning data, analyzing data processing: statistic graph method, mathematical model, a graph statistical method, and simulation models. Okay? Out of which the first 2 I have already given a previous lecture in the Facebook, and the 4th one also I have given it. But I will not. I will only concentrate today on the statistical part because of the topic you are given as a sampling procedures. Okay, so let's talk about what is sampling. Now it becomes too technical on statistics. I guarantee you that I will give you what is not known to us in the literature. Researchers don't practice these things because of some technical. I'll tell you what are the reasons why you are not practicing it. All that. Even statisticians, they are not practicing this because of the problem they get to them. No problem given is not satisfying the problem. So I'm going to explain some important steps every researcher must follow when you want to do statistical analysis of data. So let's go for traditional definition of sampling. Sampling is a process or technique choosing for a group from a population to participate in a study. All that. I've given the link of Googla 2005. You can check it. Definitions and examples, counter examples of sampling. All that. I don't teach you about sampling. All that here. I don't teach you statistics. But I'll tell you, as I told you, I'll be telling you some important key points you should follow when you do your data processing. That's objective. But to explain the record, these definitions, that's given you for sake of sampling methods. Again, I don't do this because every book in statistics, every literature in statistics, every internet searching internet have these methods: simple random sampling, systematic sampling, all that. So I don't explain any of this. I skip this. But I'm just giving you a slide to dedicate. There are methods of sampling based on your problem, based on objective, based on method of sampling. You can try all these methods, which are, I'm not discussing that. But what I'm going to discuss is, for my presentation next 10 minutes, is about some important keywords. First is population. Now, I don't show you slides because of time. I'll explain the word population, and you can explore it yourself later. What is a population? Population is a combination of all possible samples. I explained sampling in the previous slide. So now I know what sampling means. Now I define a population. Population is collection of all possible samples. Okay? Collection of all possible samples, population. What are samples? Samples is part of the population. So sampling was introduced in the last slide. Now samples are introduced. Samples are the part of the population. Sample size. The sample size is usually maintained as a secret in data processing. No researcher will be able to decide how sample size of a problem must be discussed. Every researcher comes to me, comes to a research world, asks, what is the sample size for this problem? It's an open secret, but still no one knows it. At the end of the slide, I'm going to explain, end of the presentation, I will reveal how to explore the sample size, but not now, end of the slide, because sample size decides how your data is going to behave. So I'll spend some time at the end of the slide, 2-3 minutes, the sample size. Parameters. Parameters are the one deciding the fate of the population or fate of the samples. Parameters are the one decides the fate of the population. So if you know the parameters, you know the population. If you know the population, you know its parameters. That's what parameters. In samples, we use the word as estimators. Estimators are parameters for the samples. Parameters are for the population. Estimators for the samples. Statistics. Statistics is study of population. Statistic is study of sample. Population study is statistics. Population sample study is statistics. Statistic is not a singular word of statistics. Statistic is used to study the samples. It makes lots of differences. We will see within few slides now what are the big differences. Of course, normal or Gaussian statistics. I will explain in a little later slide why this is a separate keyword one has to know to understand in statistics. Let's go to the last part of the presentation on hypothesis. Now, having collected data, having done the classification, having done the cleanliness, updation and other things, having done the graphical part, having done the mathematical part and found it is not up to the mark or it fails, having decided to go for statistical methods, having done the population samples, all that, now we come to the stage of hypothesis. What is hypothesis? The meaning for the word hypothesis is assumption. That's all. The hypothesis definition is assumption. You make what your assumption you make is called hypothesis. Hypothesis is a tentative assumption made in order to draw out and test its logical or empirical consequences. I'm giving technical definition, but I'll explain to you within few minutes how this hypothesis really works. Hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding a population parameter. This is very, very important. So what I try to say is that you must remember this is done for the population parameter. Let me just underline this. So this is what I mean. It's regarding a population. Hypothesis is for a population parameter. This is very, very important. I'll explain in a few minutes from now really how to handle hypothesis. Okay, so I'm going to explain technical definitions on this. So key words in hypothesis. In hypothesis, you require the following words: null hypothesis, alternative hypothesis, types of error, degrees of freedom, confidence limits, test statistics, and standard tables. You should know all this, and of course, one more, inferential statistics, out of which I'll be giving you till state statistics. The standard table is inferential statistics. It depends on the problem, so I'm not going to discuss in this form. Okay, null hypothesis, divided by H naught. What is the null hypothesis actually? Null hypothesis is nothing but an assumption you make. This is done based on the similar problem you have done in the past. You have done some problem, someone would have done the problem in the previous part, in the previous research. Whatever they assume, you must take the same assumption for your problem also. So you must do null hypothesis based on that, or based on the question of interest. Suppose there's a question you propose, equivalently the objective of the problem, you assume null hypothesis based on the parameters, what parameters it possesses, Like for example, if the mean is the parameter for a population, you assume the hypothesis is mean is correct. If your standard deviation is a parameter for a population, you assume that the null hypothesis is the standard deviation is correct, something like that. Based on the test, we've got different testing procedures. And another 5 minutes, I will spare some time for the testing procedures based on the population, certainly, and so on. What is the alternative hypothesis? If the hypothesis you assume is null hypothesis, I'll go back here. If the null hypothesis assumption you make, if that is true, the alternate hypothesis is false. It's false. If null hypothesis is false, alternate hypothesis is true. There are two types of alternate hypothesis. One is called single type and two type, which of course I'm not discussing because any statistician will be able to explain alternate hypothesis if you are given the null hypothesis. So this part also I'm not discussing in detail. And types of errors. Now, because of time for today's presentation, I'm again leaving this to statistician to discuss. When you have a problem, if you ask a statistician, he or she will explain to you what is types of errors. I won't explain that to you because it is well known in the statistical world. Again, confidence interval I'm not explaining to you, but I'm bringing definitions here because of time. And just showing you a small presentation on that. And then test statistics, we have different tests, p-test, z-test, f-test, goodness of fit test, chi-test test, correlation test. And in non-parametric aspect or non-parametric primary things, right? Non-parametric sample sign test, Wilkinson test, and so on. All these tests are non-parametric. Okay. So now I'm going to give an example how this is going to be worked on sample size. So next 5 minutes, I'll explain how sample size works. Then I will tell you this slide. I will show you this slide and explain these keywords. These keywords I explained in a quick stroke and complete it. So before I go to the example, I would like to show you these tests I've showed. Okay, so that's all my presentation is. I'm going to now show you an example how to design sample size in another 2 minutes. And next 3 to 4 minutes, I will talk about the keywords you have to use it in your sample size. So let's start the presentation mode. I'll go to the small presentation mode. Okay, I'll go to the presentation mode. Now I'm going to explain next 5 minutes how a sample size is going to work. So this is my sample size. I'm writing it because if I do it beforehand, it's not clear. Now, so assume that you know some statistics. Suppose you have done t-test. You have done t-test. You have done t-test. And t-test is given by a formula. There's a formula given. T is equal to, a formula is given. T is equal to modulus x bar minus mu divided by s by root n, where x bar is the mean of the sample. The mu is the mean of the population. S, the standard deviation of the sample. It can be sometimes n minus 1 if the population size is not known. This is sample size. And T is a standard T. Student t-test or standard T. So T is calculated in this way, modulus x bar minus mu by s by root n minus 1. Now this T is found, just a minute, sorry. T is found from standard table. There is a standard table, you find it. And the standard table signifies data set from 95% to 100%. I'll talk about after 1 minute what do you mean by this, please wait. So suppose you have a data, and you want to fix your accuracy as 98%. You want to have an accuracy of your data as 98%. So now you know your T is 98%. This is 98%, you know that. This is 98%. X bar, you are given the sample mean you know how to find the arithmetic mean of the sample or average of the sample. You are given the mean of the sample. So from this mathematical expression, I can find n. Let me show that quickly, some steps, very fast. So it's going to be T equals modulus x bar minus mu by S by root n minus 1. For sake of agreement, I assume that x bar is greater than mu. So I don't use the modulus anymore. What is going to happen is T equals x bar minus mu by S by root n minus 1. So simple mathematics prevails. S by root n minus 1 is x bar minus mu by T. So what happens further is maybe I just say root n minus 1 by S is equal to T by x bar minus mu. This implies root n minus 1 is S into T divided by x bar minus mu, and therefore n minus 1 would be S into T by x bar minus mu the whole square, and therefore your n is going to be x bar minus mu by, sorry, S into T by x bar minus mu the whole square plus 1. So now you know what is S, the standard deviation of the sample. You know what is T, the 98% of the data should occur in that. X bar is the arithmetic mean of the sample. Mu is the standard deviation, mean of the population. Add a 1, square it, you will get the sample size. Now, in this way only you can find the sample size. There is no ready reckoner to find the sample size. Last 2 minutes, I will go to the slide here and show you one important point which I want to explain. It's this. Yeah, so this is an explanation I want to spend some time. Null hypothesis I already explained to you. Maybe I have to spend more time on that, but because of my time slot, I'm just stopping with this. Now, degrees of freedom. Degrees of freedom, types of error, of course, we gave a slide. We talked null hypothesis, we already talked about. This also we talked about. Degrees of freedom is you have to compare one data with every other data. Suppose the n data set, a data set got n data, you have to compare that one with every other. The degrees of freedom is n minus 1. Okay, you can understand that. And then test statistics, we gave you some testing method, we gave you standard tables. Of course, I'm not showing it, and I'm not showing infinite statistics. So what is the takeaway of this presentation is you have to do the data processing, including the cleanliness of data. Second, you must use null hypothesis properly, and appropriate sample size must be chosen. And in statistics, the permissible percentage of error of any data set, the permissible data set percentage is not more than 5%. Even if it is 5.1% error are there in the problem, your data set is summarily rejected by any researcher. So ensure your data set is not exceeding 5%. And that 5% is called level of significance or p-value. So the permissible percentage of error allowed in your data set is called level of significance or p-value. It can be 5%, it can be 1%, it can be 0.1% if you want to compare with standard tables. But at any way, you cannot cross beyond 5%. Even if the permissible error, if the error happened to be in the data set is 5.01, which is more than 5, the data is summarily fully rejected by researchers because it's going to give a wrong interpretation. So summarizing what I've discussed today, is we summarize in just 1 minute what we have discussed. Then really some takeaways. So we introduce what is the data. So data comes everywhere, all that. Data collection we introduce in hierarchy. Data classification, we have spent more time on data classification, you must do it. Why classification we discussed. How classification is done also we discussed. Data processing is done. Of course, I have only done the pre-processing. Post-processing during the data analysis also we have not done because of time, but it's only data processing, pre-processing, including we introduce what data processing is, steps in data processing, advantage of data processing, how to clean data, and then graphical representation data is also discussed. Sampling procedures and methods are also we discussed. Some keywords we discussed like null hypothesis, alternate hypothesis, level of significance, keyword, confidence interval, degrees of freedom, test statistics, inferential statistics, error analysis, and so on. We discuss all that, but because of time, I'm not able to give in a detailed manner. But I've given most of these slides a link where you can refer the textbook, PDF files, or textbook, or even blogs I've given you, which will give an idea of all these words. We talked hypothesis, and then in that we discussed hypothesis and testing. So testing hypothesis we have discussed. Null hypothesis do's and don'ts we discussed. How to do null hypothesis, for example, based on the previous problem, based on the present objective of the problem, based on the parameters, etc. We also talked about alternate hypothesis, but I didn't give much importance for that because any statistician will give you single tail, two tail test, and why one has to use which, etc. based on the experience. It's easily available. Types of errors we discussed, type 1 error, type 2 error, alpha, beta, all that can be discussed. Became statisticians. We discovered confidence limit, level of significance. Level of significance is the percentage of error allowed in any problem. So given as data set, the percentage of permissible error is not more than 5%. If the permissible error is 5%, the confidence limit is 95%. If the permissible is 98%, the confidence limit is 98%, and so on. Test statistics, parametric, non-parametric. Parametric, I mean when the population data is Gaussian or uniform. When the population data is uniform or Gaussian, it's parametric, otherwise non-parametric. Sample size, and I told you how to sample size. It is usually not discussed in textbooks. So now I've given you how to do sample size based on the problem. These are references and citations. And thank you. Now I leave it the forum for questions and answers. Thank you very much for your patient listening. Thanks.
Well explained, Professor. Thank you. Thanks for the excellent session. Can I ask on behalf of participant?
Yes, sir. Yes, sir. Please, sir.
Sir, basically we use null and non-directional hypotheses in research. When to use directional hypothesis?
Now, again, this cannot be said in one answer because it depends on your problem. Even null hypothesis depends on your problem. That's why I have not explained any examples in this presentation. Because null hypothesis itself is a big task, this big field one has to discuss. Because it depends fully on your problem. If the problem is not known, it's not fully understood, one cannot even discuss a null hypothesis. So I can't answer this question very simply because the problem is not known. It is specific to the problem.
Then second question. It was a nice session indeed. Do we have some thumb rule to identify sample size irrespective of formula which you have used? Any is there any thumb rule for identifying? Yes, sir.
Yeah, there are some thumb rules followed in statistical world. For example, if the samples is less than 30, then we go for some standard tests like t-test, all that. The sample is more than 30, we go for z-test and other tests. But that is not a rule to be followed for every problem. Again, it is problem centric. There are some rules for your sample size, but most of the time, thumb rules will lead to a chaotic outcome of the problem. So better you go for mathematical expression of final sample size with the desirability of your data set. Suppose your data set is 100%, 98% clear, like perfect. Then you can take that formula which I showed you, something like that, and find the end size. Because you know that the data set is 98% perfect. No data will be 100% perfect. That should be taken granted. No data is 100% perfect. By doing cleanliness, processing of data, If you are confident your data is about 98% or 97% perfect, you can use this formula methodology to find the sample size very well. That's why it took some time to explain the formula for a small data set of 98%. But if it is not known, there is no thumb rule. Thumb rule is always there, I agree, but it is not to be practiced in a real research as such.
Yes, sir. This is relevant to English literature. Sir, for English literature, then how do we decide what category of hypothesis we should choose?
Again, the same question. I think hypothesis is problem-centric. Whether it is English or engineering, unless you know the real problem, constructing the hypothesis there is no methodology or there is no direct ready reckoner to say that this is the problem, go for a hypothesis like this. Okay. So any subject, so as far as the research is concerned, whether it's English or engineering or biology or medicine, any research problem, setting hypothesis requires the thorough understanding of the problem. So I think the answer remains same, that it's based on the problem, not based on the subject of the problem.
Yes, sir. What is the implication of central limit theorem on sample selection?
Yeah, that's a very important question according to me. I want to spend about 1 hour discussing this, but I don't think organizers won't allow that to happen. Let me explain 1 minute with the permission of organizers. Let's spend 20 minutes, sir.
Yes, sir. Please.
Central limit theorem is the most important theorem in statistics. All projects are done only because of central limit theorem. Let me explain one simple explanation of what central limit theorem says. It says, see, let me explain before that. Let me explain statistically this answer so that the researcher understand how central limit theorem works. We know binomial distribution, Poisson distribution, Rayleigh distribution, uniform distribution, Maxwell distribution, even so many distributions are available. All these distributions are Poisson distribution and so on. All these probable distributions are excellent and they are very specific to a given problem. Suppose there is a problem which has got memoryless property, Poisson distribution is the best distribution. If there is a problem which has got, for example, initial property forgotten, like P is infinity, the probability is infinity, you go for exponential distribution problem and so on. So each distribution is discussed. You can also discuss one distribution and so on. Central limit theorem says that every distribution, today, present, past, and even future, they all behave like the Gaussian distribution. The central limit theorem says all the distribution, the past distribution discovered, the present distribution we are using it, even in the after 20,000 years later, somebody is a new distribution, even that will be fitting into a Gaussian distribution. That's why my slide has got one point on Gaussian statistics, but because of time, I couldn't give it. So Gaussian distribution guarantees that every data set practically fit into the Gaussian distribution. The central limit theorem guarantees that. So if you have no other go, you can take your data set, apply central limit theorem, and go for the Gaussian distribution if nothing is available. But you should ensure that nothing is available first, because you have to ensure all the stepwise segregation. Then, if everything fails, then go for the Gaussian distribution, because central limit theorem guarantees Gaussian distribution is the one fitting for every data set you collect, whichever data set you collect.
Sure, sir. We should have, yes. Yeah. We should have permitted you for 2-3 sessions. Next time we will plan in a grand manner. And today, of course, due to time issue, we wish to close the question and answer session. I request Mr. Ganesh Babu to display the appreciation letter issued by our beloved registrar. Mr. Ganesh, can you do the honors?
1 second.
Meanwhile, I will propose the vote of thanks also.
Yeah, you continue, sir. I'll post it.
Actually, I'm really grateful to Dr. A.G.Srinivasan sir, such a great person doing wonderful work for our young researchers who have joined for this STTP. Thank you, Dr. A.G. sir, for giving acceptance, for accepting our invitation and to be with us on today. Really, we are glad with all your insightful knowledge. Today, we have gained a lot to understand about data collection, what is the sample size, how we have to take hypothesis test, etc. In particular, just I wanted to mention a word here. I have done this hypothesis because of that one only. During my PhD days, I got very good publication. That time it was IEE. Later it converted into IET. Like that, if we give full dimension to our research, not doing experimentation alone or simulation alone, if we could give this hypothesis as a part of our thesis, that work will be recognized worldwide. And thanks to our statisticians, I got few very good publications because of this kind of introduction. Thanks to your this input to our young researchers, this has made a very good idea. Unfortunately, due to time restriction, we are limiting your speech. And at this moment, I'm promising our participants that we will share the entire video of this session to our in our WhatsApp as well as a Telegram group. Also, we will share our content, PPT content of Professor A.G.Srinivasan sir today presentation to our group. And please feel free. And we thank Dr. A.G.S. sir. We are really grateful. Can I read that, sir? We are really grateful to you for delivering an amazing session on the topic data collection, processing, and hypothesis on the second day, first session 10 to 10 a.m. In our STTP. Your session turned to be highly knowledgeable and gave participants a meticulous understanding and complete clarity of the methods of data collection and data collection, processing, and hypothesis that are to be implemented during the course of research. The participants of STTP appreciated your performance with excellent feedback, and this adds another feather to your cap. Nevertheless, to say the feedback also helped a great deal in elevating the name of our institute, and we feel extremely glad and thankful to you, Dr. C.B. Palanivelu, Registrar. Yes, sir. Your words, please.
Yeah, thank you, sir. Thank you very much for the opportunity given to me. I would like to thank everyone, Dr. Manivalan sir, Vidya, Ganesh Babu, every one of us. No individual names are required to say. Everyone of us for the opportunity given to me, and the participants also patiently listen to my small session. And thank you very much.
Thank you, sir.
Thank you. Participant, yesterday, due to technical problem, we could not immediately send you the YouTube link for yesterday recording. But fortunately, today we have overcome all the problems, and I'm promising you, afternoon itself, you will be given that YouTube link of the entire recording. And of course, we are working hard to retrieve that what happened yesterday. Those apart from PPT sharing, we will share that recording also in due course of time. We will meet, yes, Vidya, because our Dr. Prasida madam is readily available with us.
Yes, sir.
Yes, in
we'll
another
just
5
take,
minutes. Yes,
5 minutes, sir?
Yes, yes.
It's 11:20 now, sir.
Yes,
We'll resume at 11:25.
No, 11:25.
Okay, participants, we'll just disperse for a small tea break. Our second session speaker is here, Dr. Prasida. So we'll resume our session at 11:25. Thank you. Welcome, Dr. Prasida.
Good morning, madam.
Thank you.
Good morning, sir. Good morning, ma'am.
Good morning, madam. Madam, you can check your presentation with Mr. Ganesh Babu.
Okay, sir.
Yes, ma'am.
I'll do that.